Hello, good day viewers, and welcome to my YouTube channel. This is going to be another wonderful section. And let me quickly say this, I have had a whole lot of people, messaging me, a whole lot of comments. They are waiting for the video for this year WAEC. Something huge is coming. So let's just calm down. We are still working on a whole lot of things to serve us better. So very soon I'm still going to be uploading the videos for WAEC for this year. So, and I'm sure it will bless us tremendously. So just stay tuned. If you have not subscribed to the channel, please do that so that when we post any video on the YouTube channel, you would be notified. So the video will come. I'm promising that the video will come for this year WAEC. It will definitely come. So if you know somebody writing WAEC, your colleagues, your friends, just tell them to subscribe to the channel because the video will be dropping very, very soon. And for people that are writing JAM, I've had a whole lot of videos on this channel. I want to believe you are following the teachings here. And for today, I'll just quickly do something. I will explain a concept because I had some subscribers chatting me to put clarifications to this thing I want to do today. So I will put a whole lot of clarification to the topic for today so that at the end of this video you should really understand what this very particular topic is all about. And for my subscribers, I've seen a very instrumental development on the channel that has been instrumental. A whole lot of people have been sharing the video, they have been sharing the channel. Thank you so much. And if you are just watching this very particular channel, please endeavor to subscribe to it. So today I want to explain something. For those of us that have been following the teachings here, I did a video on bonding. If you remember, I explained explicitly about what bonding is all about. We took them step by step, and a lot of people chatted me that they really enjoyed the teachings. But I want to put clarifications to some things and explain better what the subscriber actually wanted me to explain. So stay tuned and make sure you watch the video till the end so that you get the teachings today. Now, if you remember when I taught the covalent bond or covalent bonding, and we said that covalent bonding actually deals with the sharing of electron. It is possible for electron to be transferred and it is possible for electron to be shared. If you don't understand this, please go to the channel. There are videos on bonding. Go and watch them. So for covalent bond now, you will agree with me that in covalent bonding, electrons are shared between participating atoms, which means there are interactions. There are interactions between electrons. Now, when these electrons interact, they tend to primarily form some kind of bonds. Very, very important. Because the interaction of atoms the interaction of electrons will actually bring about some kind of bonds. And if you remember in the last video, like we did hydrogen gas, and we said, they will always share. Hydrogen has one electron, and you have two hydrogen here, so they will always share their electron, and this becomes what? It becomes a covalent bond. Now, this interaction of electron here, the interaction of this electron can give rise to bond, and that's what I want to talk about today. Because definitely this is an orbital and this is another orbital, they are overlapping. So the overlapping of orbitals, which involves the interaction of electron, can bring about what we refer to as either a sigma bond, and that's what I want to put clarification to, a sigma bond or a pi bond. So I will explain sigma and pi bond, so stay tuned. It's either it becomes a sigma bond or it becomes a pi bond. So in covalent bonding like that, when electrons interact with each other, they primarily form what we call some kind of bonds. And the bonds can either be sigma or the bonds can either be pi bond. Now, if you talk about sigma bond, now let's quickly take that. If you talk about sigma bond, what do you mean by sigma bond? When you talk about sigma bond, you are talking about head-to-head overlap. Please pay attention. Head-to-head overlap. Meaning, if I have, let's take for example, maybe I have a pencil like this, and I have another pencil like this. You know, it is possible for me to join these two pencils together. This one I can join like this, head to head, very possible. And I can decide to join side by side. I can decide to join this pencil like this. So if I have head to head overlap, when atomic orbitals come together and they are head to head overlap, some school of thought, we say they are axial overlapping. We are still saying the same thing. But the common one for quick understanding is that when atomic orbitals come, they come in form of head to head overlap. Then we said they are sigma bond. So when I have head to head overlapping of atomic orbitals, then the kind of bond formed will be a sigma bond. I will explain so that we will understand. While if I have a side by side overlap, if I have a side by side overlapping or overlap of atomic orbitals, what will be formed will be a pi bond. Please pay attention to that. If I have a head-to-head overlap of atomic orbitals, then the kind of bond that will be primarily formed will be a sigma bond. While if I have a side-by-side overlap of atomic orbitals, what will be formed will be a pi bond. Now, for more clarifications, let's see this so that we understand what I'm talking about. Of course, in our normal chemistry classes, we have done orbitals. We have done s orbital, p orbital, d orbital, f orbital. It's on the channel. If you have not watched the video, go and watch it. And we know that our s orbital is spherical and our p is like a nodal bell. We know that already. Now let's see the possible outcome, the possible overlapping of atomic orbitals. What are the possible overlapping of atomic orbitals? Let's see that. I can have an s orbital, okay, plus another s orbital. And when they overlap, they give me this kind of atomic orbital. So which means this is an x orbital and this is another x orbital. Now they are overlapping head to head now. This will give rise to what we call a sigma bond. Now, this is S and S. It is possible for me to have S orbital plus I have P orbital, okay, coming together to give me this and give me this. So this is S orbital and this is P orbital coming together to give me an SP orbital. So the kind of overlap here, if you look at this, you see the P orbital is actually overlapping with the S orbital. The kind of bond that will be formed here will also be a sigma bond. And I can have my P orbital, okay, plus another P orbital to give me an overlap, which is like this. Can you see that now? So this is P and this is P orbital. So it will also give me this overlap here is also a sigma bond. So the possible overlap for sigma bond to be formed, the possible overlap is I can have S and S orbital to give me what? A sigma bond. I can have X and P orbital to give me another sigma bond. While I can have P and P orbital to give me what? To give me another sigma bond. So the possible overlapping of my sigma bond, which involve head to head, connecting them head to head will give rise to what we call a sigma bond. Now, for pi bond, the possible overlap for pi bond to be formed is always formed between my P and P. I can have this plus another P orbital to give me this, okay, where they overlap like this. Can you see that now? So if you look at this, we have our head-to-head overlap, which is giving rise to our what? To our sigma bond. While if you look at this, it's just like we are joining them side by side. So this gives me a what? A pi bond. Very, very important. So if S and S comes together, it gives me a what? A sigma bond. S and P come together in this kind of overlapping, it gives me our what? Our SP, which is what? Also a sigma bond. While if my P and P comes together, joining them head to head like this will also give rise to what we call sigma bond. But if you look at this, if they are overlapping side by side, if they are overlapping side by side, it will always give us what? A pi bond. And that's the reason why if you check almost all the first bond of any atomic orbital, it will always give rise to a sigma bond. So for all types of combination, the first bond that will always be formed will always be a sigma bond. I will explain that when times come to go. I will give example. Now, the usefulness of our sigma and pi bond is that we can use it to determine what we call our bond length. Very important. You can use it to determine what we call our bond length. You can use it to determine what we call our bond strength. And we can use it to determine what we call our bond energy. Yes, the usefulness of our atomic orbitals here is that we can use it to determine what we call our bond length, we can use it to determine what we call our bond strength, and we can use it to determine what we call our bond energy. How can we determine our bond strength, our bond length, and our bond energy when it comes to either sigma bond or pi bond? Now, if you look at your sigma bond, there is maximum overlapping. If you look at this, the proximity of the atom is nearer, and that's the reason why if you look at your P and P here, there is proximity. There is this maximum overlapping between P and P, which implies that the bond energy, because of the proximity or because of the maximum overlapping for P orbital, the bond strength and the bond energy will be greater than sp, while the bond energy of sp will be greater than this very particular ss overlapping, while the one that will have the least bond energy will be this, because of the distance. So if we look at the bond strength now, the more you overlap or your proximity determines your bond length, will determine your bond strength and your bond energy. What am I trying to say? Now let's take for example, look at this. Look at the proximity of this one. There is maximum overlapping between this P and P, which means our P and P will have the largest bond strength. And if they have the largest bond strength, definitely they will have the largest bond energy because of the proximity of their overlapping. So after this, our sp will follow because of the proximity between this and this, while our s will follow because of the proximity between this and this. Then our P and P in this form, this very particular pi bond will follow. So this is a sigma bond, okay? This is also a sigma bond. This is also a sigma bond form. Then this will be a pi bond. So the bond length, and if you look at the bond length, look at the distance between this. And look at the distance between, look at the overlap, look at the distance between this. You can see the shorter the distance, the more the bond strength and the more the bond energy. I hope we are getting that. So the more when the distance increases, bond energy and bond strength will decrease. So for P and P has the largest bond length. So definitely the bond strength and the bond energy will actually reduce. And because your P and P, there is maximum overlapping, so the distance will be shorter. Then when the distance, that's the bond length, will be shorter. When the bond length is shorter, the bond strength and the bond energy increases. So let's take examples. How can we determine if the bond is either pi or sigma? How can we determine? Let's take for example our CH4, let's use these molecules as example. Let's determine the number of pi bonds and the number of sigma bonds that we have. We can have these two. Let's take these ones for example. So if we look at this CH4, the structure is like this. Okay, and I've said that for every first bond formed between two atoms, it is always a sigma bond. For every first bond formed between two atoms, it will always be a sigma bond. So if you look at this will be a sigma bond because it's the first bond formed between carbon and hydrogen. Between this and this again, there is a bond, a sigma bond. Between this and this again, there is a bond, single bond. will be a sigma bond. Between this and this again, there is a bond, will be a sigma bond. So the number of sigma bonds you have here is 4. Why do we have any pi bond here? No, because all the bonds we have here, they are single bonds. And if they are single bonds, definitely there is no pi bond there. It is only sigma bond. Let's see water too. The molecules of water, the shape looks like this, okay? Now, we have said that the first bond formed between any two atoms will definitely be a sigma bond. So if we check, is this a bond? This hydrogen, this oxygen, a bond is formed between hydrogen and oxygen. Definitely this is a sigma bond. A bond formed between oxygen and hydrogen is what? It's a sigma bond. I hope you are following. So do we have any pi bond here? No, because you have only one bond formed between this and this. So the number of sigma bonds that you have here is what? Is 2. I hope you are getting that. Let's look at this. C2H4. We have this, okay? This will be the structure for this. So let's see. We have said the first bond formed between two atoms. First bond formed between two atoms is always a sigma bond. So we can have, this is a single bond, definitely. This will be sigma, single bond, sigma. Between carbon and carbon, you have one bond first. This is a sigma bond. Between this and this is a sigma bond. Between this and this is sigma bond. So we have 1, 2, 3, 4, 5. So number of sigma bond is 5. Do we have a pi bond here? Definitely yes. Because we say for every first bond formed between two atoms is always a sigma. So if another one is being formed, either double or triple bond, it becomes a pi bond. So meaning we have a double bond here, meaning this one will be pi. So the number of pi bond here is 1. Can we see that now? So the number of sigma here is 5, while the number of pi bond here is 1. So let's see for this. Let's see for this. We have this. This is the structure for this. I hope you are still following. This is the structure for this. Okay? This is the structure for this. Let's see. First bond, sigma, 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 sigma bond, sigma bond, sigma bond. You know, because it is the first bond formed between those atoms. So this is also sigma, and this is also sigma. So we have 1 sigma, 2, 3, 4, 5, 6, 7, and 8. So the number of sigma bond here is 8. Do we have pi bond here? No, because the first bond formed between two atoms is always sigma, and we don't have any double bond here. Definitely, the number of pi bond here is what? Is 0. Can we see that? Let me take one example again, like CO2. CO2 will be, this is the shape for CO2. If you don't understand all these shapes, you can watch the video on the channel. We have done all this. So let's look at this. First bond will be sigma, right? First bond again, sigma. Definitely this is the second bond. We have said second or third or any bond formed after this first one will always be a pi bond. So meaning this one is pi and this one is pi. So meaning the number of sigma bond we have here is 2, while the number of pi bond we have here is also 2. Can we see that now? So very, very easy. When you talk about the sigma bond, we are talking about side-by-side overlap of atomic orbitals, okay? And the possible overlapping, and when you talk about pi bond, you are talking about, when you talk about sigma, you are talking about head-to-head overlap. When they overlap head-to-head, then we have a sigma bond. Why for pi bond now? For pi bond, we are talking about side-by-side. When those atomic orbitals overlap sideways, then a pi bond is formed. And the possible overlap of those atomic orbitals is what we have mentioned here. You know, we have this, we have this, we have this. Sigma bonds will be formed. But when they overlap like this, when they overlap side by side like this, then a pi bond will be formed. So very, very important. We can actually determine our pi bond, number of pi bond that is in a particular molecule or atom, and we can determine the number of sigma that can be there. So from this now, we can give some differences between pi and sigma bond. We can have some differences between sigma. Let's see if we can have some differences between sigma and pi bond. Let's see if we can just mention a few. It between sigma and pi bond. What are the differences between sigma and pi bond? So number one, we said this, it involves what? Head-to-head overlap. Head-to-head overlap. Overlapping of atomic orbitals. That's number one. While our pi bond involves what? It involves side to what? Side, or side by side overlapping of atomic orbitals. That's number one. Very correct. Number two, our sigma bond is represented. Our sigma is represented by a sign like this. When you see this kind of sign, then you know you have written your sigma bond. Okay. Why this one is represented? It is represented by our normal pi, like our mathematics pi. Okay. So number three, very, very important. Your sigma bond is stronger. Yes, is stronger. While your pi bond is weaker. A lot of people will now look at it and say, no, it's not supposed to be so. Because your pi bond talks about double bond. While your pi bond talks about double bond, your pi bond talks about triple bonds. Okay, but your sigma bond talks about single bond. So why is it possible for your pi bond to be weaker and your sigma bond to be stronger? Let me show you something. Now, if you look at this, for some of us that are familiar with organic chemistry, let's take for example, if we have a molecule like this, just an example, please pay attention. In organic chemistry, if you have something like this, there's something we call addition reaction. Now, if you bring hydrogen molecule to actually attack this very particular structure, what it will be giving us will be this. Why? What happened? If you look at this, it has broken the double bond here. To single bond. And we know that the first one that will always be formed will be a sigma bond, while the second one that will be formed, or the third, will be a pi bond. So if you look at this structure now, the pi bond has been broken and the sigma bond still remains. So if you have double bond or triple bond and anything is coming to attack it, the first one that will be broken will be the pi bond, which is the second or the third one. I hope you are getting that now. And that's the reason why, if you check most compound in organic chemistry that have triple bond, like the alkyne or the alkene, when they attack them, they will break them down. They continually break them down into the single bond, which makes your sigma bond to be more stronger than your pi bond. So our sigma bond is what is more stronger than our pi bond. Very, very important. And number four, the bond length of sigma overlapping, is what? Is shorter. I've given an example. You know, when our p orbital plus another p orbital reacted, you know, we're having something like this. So the overlapping here, you cannot compare it to when your p reacts like this, you know, and your p reacts like this. And we are having something like this, where you have them overlapping. Can you see that now? So the bond length of sigma overlapping is shorter. A good example is this. Why the bond length of your pi bond is what? Is longer. That's number four. Let me give you the last one. We have a lot of differences between them. Let me give another one, which is number five. Your sigma bond is independent of pi bond. What do you mean by that? It is possible in a molecule for you to have only sigma bonds. Yes, it is very, very possible for you to have only sigma bond in a molecule. Look at this one. You have only sigma bonds here, no pi bond. You have only sigma bond here, no pi bond. Can you see that? It is possible for you to have your sigma bond alone. But for you to have pi bond, there must be a sigma bond. Because if you look at this, you have a pi bond here, which is 1. We already have sigma bond, which is 5. Because the first bond will always be sigma bond. And there is no way you can form double bond without a single bond first. I hope I'm getting that. There is no way you are going to form a double bond or a triple bond without you forming one bond, a single bond first. So your pi bond is what? Is dependent. Is dependent on sigma bond. Pi bond is dependent on sigma bond. So those 5 examples are what we can actually read in our lecture time to see the differences between our sigma bond and our what? And our pi bond. But don't forget, the first molecule will always form a sigma bond. The first bond between any 2 atoms will definitely form a sigma bond, which is a single bond, while other subsequent overlapping after the first bond, we can have double bond, we can have triple bond. So very quickly, I will just give us this. You can use the comment box to actually answer the question, how many sigma and pi bond do you have in the following? You can just do that on our own to be sure we understand the topic. How many sigma bond do we have in hexane? Okay, how many sigma bond, how many pi bond do we have in hexane? How many sigma bond do we have in ethyne? Very, very important. How many do we have in SO2, for example? How many do we have in NH3? We can just try this on our own. So just try to draw their structure and explain how many sigma bond do we have here, how many pi bond do we have here, how many sigma bond do we have here, how many pi bond, how many sigma bond, how many pi, how many sigma bond, how many pi bond. So very, very important. When atomic orbitals overlap, they actually interact, and when they interact, it's either they form a sigma bond or they form a pi bond. So very, very important again. The first bond formed between 2 atoms is always a sigma bond, while other subsequent one, maybe double or triple bonds, will definitely be a pi bond. And that is that. So for sigma and pi bond, I hope that this very particular class is clear enough to actually make us differentiate between pi bond and sigma bond. So very, very important. So please, if you are just watching this channel, I want to urge you, I want to persuade you to actually subscribe to this channel so that other videos that will be dropping, you would be notified. Thank you.